In this video we're looking at programming basics, which is 11.1 in the CIE 9618 specification. So what you need to be able to do is implement pseudocode from a design. So convert a program flowchart or a structured English design into pseudocode statements. So effectively writing programs in pseudocode. You need to be able to declare variables using the declare command word. Explicitly giving data types to your variables. You need to be able to write expressions, ones that combine arithmetic and logical operators correctly and using the correct precedence order. You need to be able to declare and initialize constants using the command constant. Assign values to variables. In CIE pseudocode that's done with the arrow. And use input and output statements. So declaration and initialization of constants first. So a constant is something that stores a value that cannot change during program execution. It can only have a single value all the way through the execution of a program. And the CI pseudocode syntax for this is the word constant, followed by the name of your constant, the equals sign, and the value you want to give it. You don't have to specify the data type for this because it's inferred from the value that you give it. So if you give it an integer value, it knows that that constant is an integer. So why do we use constants? We want to give things a fixed value that can't change. We want to have a meaningful name for it. This prevents accidental changes elsewhere in the program. So you can't accidentally increase the VAT rate, for example, in the middle of a program and not realize and get errors in your results. Another advantage is you only have to edit it in one place. So if you do want to change it from execution to execution, you can, after the program's run, you can go and edit the code and change the value of the constant. But you only have to change it in one place. So all the places that use it use that new rate, that new value automatically. You don't have to change lots of places, and you might miss some and then get errors in your results again. So on the right there's an example. We've defined various constants, the VAT rate, maximum students, and so on. And you just use them like normal identifiers in your programs. You can refer to it exactly the same way you would refer to a variable. You can use it in parts of calculations. You can input, output it, do anything you want with it. The only thing you can't do is you can't change it. If you try and change it, you'll get an error. So now we look at variables. And variables are something that stores a value that can change during program execution. It doesn't have to, but it can. So note the difference between constant and variable. Constant cannot change during program execution. Variables can change during program execution. So to set up variables in pseudocode, we say declare the name of the variable, colon this time, not equals, a colon, and the data type. Obviously, we don't have to give it a value when we declare things. Some languages do allow you to declare and assign a value, like an initial value, but here we're just doing the declare. You can declare multiple variables of the same data type in one line. You just separate each one by commas. And the data types you can choose in pseudocode, we've got integer for whole numbers, real for numbers with a fractional part, char for a single character, string for any sequence of characters, boolean is just true and false, and date will give you a date value. So on the right we have some examples. We're declaring various variables with their different identifiers and different data types. You can declare multiple on a single line, like length, width, area, if they're all real. And you can declare arrays in the same kind of way. Slight differences there. You have to actually say the word array, the size of the array from the lower bound to the upper bound in square brackets, and of whatever data type you want them to be, in this case of integer. So declare scores, which is an array from 1 to 30 of integer. So assignment. The assignment operator in CIA pseudocode is the arrow rather than the equal sign, which is common in other pseudocode versions. So we just say the identifier name on the left, arrow pointing into it, and then whatever value or expression on the right that we want to go into the identifier on the left. So it's always going from the right to the left. The variable must be declared before you try and do that in pseudocode. So a declare would have to have come before this. The value and type must be compatible. So if we're trying to put an integer into a string, then that's not going to work. We can do things like put an integer into a real, but we can't put a real into an integer. So some work and some don't. It just depends whether they will make sense or not as to whether they're allowed. Anything on the right hand side is evaluated before the move is attempted. So when we talk about an expression, it means it has to work out the result of that expression first, and then whatever the result is gets moved into the left. So on the right we have some examples. We've declared some variables, integer, strings and reals. Assignment age of 16, you just say age and then the arrow into age, and the value 16 goes into age, and saying Aisha goes into name. Expressions there below, total plus bonus and age plus 1, they're very simple expressions, but they're resolved and then put into whatever's on the left hand side. So we have arithmetic operators. These can be used to combine any identifiers, whether it's constants, variables, function calls, whatever it might be, calculate some kind of result and then put the answer back somewhere. So in the first case we've got addition, which is very simple. You just add two things together. Subtraction, multiplication, division, normal division, sum with slash count. So in that example, slash means normal divide, and that will give you a potentially fractional part. If you don't want the fractional part, you can just do integer division with the word div. So the operator is div. And if you want the remainder from that division instead of the whole part, then you get the mod function, the mod operator in this case. So we say, for example, the remainder becomes minutes mod 60. And the precedence order is important to remember for these operations. It's just like maths, where some people might be used to using terms like BIDMAS, where you do things in a particular order. We have the same thing for operators in computing. In this case, we do any multiplication, divide, divs and mods first. They're the highest priority operators. If there's more than one on the same line, we just do it left to right. So you read and carry out the operations from the left to the right. Same for plus and minus. They're the same priority as each other. We just do it, evaluate it left to right. And then we can use parentheses or brackets to force the order you want to override the normal precedence, or to just aid clarity and make it clearer for people reading your code. We also have relational operators and logical operators. So relational operators compare two values and produce some kind of Boolean result, true or false. And logical operators are used to combine Boolean expressions, or parts of Boolean expressions. So relational equals is just a straight equals in pseudocode, not double equals, just a single equals. Not equal to is the less than and the greater than symbols next to each other, rather than something like Python, which is exclamation mark equals. Pseudocode is like that. Greater than is that symbol, less than symbol, greater than equal to, and less than equal to. So they're all the relational operators you can use. Then you have the logical operators of and, or, and not. For and, both parts of it need to be true, or all parts of it need to be true for the whole expression to be true, or any one of them has to be true, and not just reverses or inverts the Boolean values. So we can combine arithmetic and logical operators. Obviously, when we want to do some meaningful programming, we're going to be having lots of different values, mixed values, and need to test them and see what the outcome will be. So in this example, we're defining a couple of constants. Notice the use of the equal sign there. So we can say constant pass mark equals 50. Constant distinction mark is 85. And again, note that we don't have to say the data type there. We just say equals and the value. And from the value we give it, it works out the data type for us. And then we declare some variables. We've got mark, attended, has passed, and has distinction, integer and booleans. And then we're doing some assignment. So saying mark becomes 78, attended becomes true, and then has passed is a boolean. So we want to say has passed becomes either true or false depending on this expression, this boolean expression. So we say mark is greater than equal to pass mark and attended. If those are both true, then has passed will be true. And for has distinction, mark is greater than equal to distinction mark and has passed. If they're both true, then has distinction is set to true. We can also do inputs and outputs. So the command for that is input, and you input to an identifier. Obviously that variable that's identified must be declared first in pseudocode, so it knows what you're talking about and what memory and what type it should be. Execution pauses until the user types the value and presses enter. So input can actually be used as a way of pausing programs to let you see what's going on, but the main purpose is to get data input in to be processed. And the value stored as you have typed it, exactly character by character as you've typed it. That means that it will be a string value that you get typed in. And if you don't want a string, if you want it to be a number, then it's the programmer's responsibility to cast that to a different data type. So for example, to make it an integer, you'd use the int function and convert the string into an integer. Only one identifier put in input statement, so you can only input into one variable at a time with this pseudocode. So in our example, we declare some variables, student name and mark. Output a message before you do inputs, otherwise the user of the program doesn't know what they're supposed to be doing. They just hear a cursor flashing on the screen and no idea what that's supposed to mean. So always try and put outputs before your inputs. We output enter student name, they input it, we put it into the variable called student name. Same for the mark, we output a message, input the mark into that variable, and then we can do whatever we want with it. So if you want to cast it to an integer, if we think that should be an integer, we could use the int function to do that. So if int mark is greater than 50, then do something. We can also output, and output displays one or more values on the screen. Those values could be actual literal values, they could be variables, they could be constants, they could be expressions, mixing everything together. So you just say the word output, and then you put in at least one value, one thing that you want to output. And if you want to output more than one, just comma separate them, and they all come out on the same line, one after the other. So a literal string is a string in quotes like the first one, so outputting a literal string. Second one, we output mark, so we're outputting the contents of the variable. The next one, we're using an expression, which is mark plus bonus, and outputting the result of that expression. And several items together, we just separate them there by commas. So we've got name, comma. Notice the space after the quotes before the scored. So we get a variable and a blank space, and then the word scored, another blank space, and then the word mark. If you forget the blank spaces, it will just squash everything together and it looks strange. So try and remember to put the spaces in or make it clear there's a space there. So in our example, we declare a couple of variables again, assign values to them, and then we're outputting them onto a single line. So in pseudocode, there are some functions that are built in that are actually mentioned in the pseudocode guide. These include things like the int function we just used, rand to create random numbers. Rand x will create a random number, a real number between 0 and x inclusive. Length of string, we can work out, and uppercase, we convert things to uppercase. You don't have to worry about trying to remember every single function that you might need. If a question uses one that's not in the pseudocode guide, it will definitely be explained in the exam question itself. Some common mistakes to avoid. Don't use the arrow for constants or the colon. You use equals when you're assigning the constant. So you just begin with the word constant, the name of the constant, and then the equals sign and the value you want to set in that constant. Don't forget to declare all the variables and give them data types before you start using them. Notice the difference between normal division with the slash symbol and div, which just gives you the integer quotient part, sometimes called integer division. Remember the precedence order for your arithmetic operators. There is also precedence for logical operators, and that's the precedence for those is not, and or. So not has the highest priority, then and then or. And again, if there's more than one on a single line, then you just read left to right. So if they're the same level of precedence, you just read left to right. Input with an expression. So only have one single identifier as the place that you're putting your input. You can't have an expression or more than one identifier. And don't forget to separate your output. If you're separating multiple items to be output, don't forget you need the commas to separate them. Alright, there's the programming basics. The next time we look a little bit more about the program constructs.